In our first video, we're going to look at the Pythagorean Theorem, and we're going to look at metric and imperial conversion. The Pythagorean Theorem. For any right triangle with hypotenuse C and legs A and B, we know that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So C squared is equal to A squared plus B squared in this diagram. Recall that the hypotenuse is always across the right angle. And what I mean is, if we go to side C and we go across from it, you should see the right angle. Second thing you should note is that we're going to use capital letters for vertices and lowercase letters for sides. So you see that side C, which is given a lowercase letter, is going to be opposite vertex C, or angle C. Side B is given a lowercase letter, and that is opposite vertex B, or angle B. And we see that side A is given the lowercase letter a, and vertex A, the angle opposite to it, is given a capital A. Let's now try using the Pythagorean theorem. So for all our examples, the best way to deal with them is to label your diagram, to state an equation, and finally to solve. So I'm going to call this vertex A, this vertex B, and this vertex C. Across from vertex C is side C. Across from vertex B is side B, which is 18 feet. And across vertex A is side A, which is 15 feet. So C is going to be our unknown. So we've labeled our diagram. Second step is to write out the equation we're going to use. So we're going to use Pythagorean's theorem to find the hypotenuse of this triangle. So we have C squared equals A squared plus B squared. We know the values of A and B, so we're going to sub them in next. So we have 18 squared plus 15 squared. At this point, we can use our calculator. So we get a C squared value of 549. Since we want to determine side C, we need to square root both sides of the equation. We should see that the value of C, or the hypotenuse, is approximately equal to 23.4 feet. So I use a dot above my equal sign to show that I've approximated this answer, that it's not exactly 23.4, but is approximately 23.4, and I've also included the units of measurement. Let's do this one more time. So again, first step, let's label our diagram. So capital letters for the vertices. So we have A, B, and C. C is where the 90-degree angle is. So this time our hypotenuse is given, and it's 3.1. Side A is going to be 2.0, and this time side B is our unknown. So now we state our formula. So we have C squared equals A squared plus B squared. This time we have the left side of the equation with a value. We have 3.1 squared equals 2.0 squared plus B squared. The next step is to get the B squared on its own, because we're trying to solve for side B. So to do that, we're going to minus 2.0 squared on both sides. And 2.0 squared minus 2.0 squared will equal 0. And what we're left with is that 3.1 squared minus 2.0 squared is equal to B squared. Next, we can use our calculator, and we see that we get B squared is equal to 5.61. And then the last step is to square root both sides of our equation. So we end up with b equal to approximately 2.4 meters. Now, just as a tip, you should note that when we're solving for the hypotenuse, as in this example, we see that we're going to have addition because the side is longer than the other two. And if we're solving for a side that's not the hypotenuse in a right triangle, notice we end up with subtraction. So if our side length for B was longer than C, you should note that you've made a mistake since the hypotenuse is the longest side of a right triangle. So next is metric and imperial conversions. So for this example, page 3 has the conversions that you're going to need. And for most questions in the homework, if there is a conversion required, there will be the conversion factors included. For example 2, rewrite each pair of measures using the same units. So I have 28 meters and 2.1 kilometers. So let's say we pick kilometers and we want to convert them to meters. Looking at page 3, we'll see that we're given 1 kilometer is equal to 1,000 meters. Then 2.1 kilometers is equal to 2.1 times 1,000, which equals 2,100 meters. So part B, 140 inches looks okay, but now we want to change 3 yards and 1 foot. So if you look at the conversions again, we can see that 1 yard equals 36 inches. So then 3 yards equals 3 times 36, which equals 108 inches. So that is the first one. Then we have 1 foot, and we'll see that we're given that 1 foot is equal to 12 inches. So if we add this up together, 3 yards and 1 foot is equal to 108 plus 12, which is 120 inches. So there's the final answer for this example. There are some questions from the book that you can try. The first set are Pythagorean Theorem questions, and the second set relate to conversions.